Hello guys, in this video talk about Solidigm D5-P5336 SSD review. Subscribe our channel and end of this video comment your opinions about this video. Solidym's D5-P5336 SSD offers massive capacities up to 61 TB that shift storage paradigm. Solidigm D5-P5336 review, additional benchmarks and our conclusion. Solidym's D5-P5336 SSD offers massive capacities up to 61 TB that shift storage paradigm. The new Solidigm SSD D5-P5336 targets read-heavy workloads and features the company's latest QLC NAND flash memory to achieve massive storage capacities up to 61.44 TB. Solidigm is expanding its data center SSD lineup again, with a new series of drives designed to further maximize storage density and reduce TCO. The new Solidigm D5-P5336 series is a lower-cost option that slots in behind the company's mid-range D5-P5430 series of drives, but the D5-P5336 targets more read-heavy environments and ratchets capacities up significantly. In fact, the 61.44 TB Solidigm D5-P5336 we've got on hand is the highest capacity SSD ever released to date. The Solidigm D5-P5336 series is outfitted with the company's latest 192-layer, 171GB QLC NAND flash memory to drive costs down, but capacities up to 61.44 TB, to cost-effectively maximize storage density per server beyond what's possible with HDDs, or other SSD for that matter. The D5-P5336's SSD controller and platform is similar to Solidym's other D5 series drives, but its NAND configuration and firmware tweaks change the value proposition considerably. Take a look at the high-level features and specifications below and then we'll dive in headfirst to see how the new Solidigm SSD D5-P5336 performs. Solidigm SSD D5-P5336 specifications and features. The new Solidigm SSD D5-P5336 series drives we'll be showing you here will be offered in a variety of form factors, including U2, 15mm, E1, L, 9.5mm, and E3, S, 7.5mm, and they will be offered in capacities from 7.68 TB all the way on up to a massive 61.44 TB, the smaller E3. S 7.5mm drives top out at 30.72 TB, that's double the capacity of the D5-P5430 series for those keeping track. The Solidigm D5-P5336's highest capacity drive shifts the paradigm versus traditional hard drives in environments that require gigantic pools of storage. At this point in time, there are no HDDs that come close to the Solidigm D5-P5336's maximum capacity, and they can't compete with SSDs in terms of performance or power either. The comparison above, provided by Solidigm, demonstrates how the Solidigm D5-P5336 can impact real estate, costs, and ultimately TCO. This kind of massive capacity in a solid-state drive, SSD, may be a game-changer for some clients, especially in the current landscape where AI and ML, and its huge storage requirements, become ever more pervasive. The Solidigm SSD D5-P5336. The specs for the drives vary somewhat between capacities and form factors, up to 1.005 M, 43K random IOPS, and sequentials up to 7 GB per second reads and 3.3 GB per second writes, but the Solidigm website has an easy compare feature available, should you be considering its various form factors. At the core of these drives is a proprietary, native, PCIe Gen 4 NVMe controller paired to 192-layer QLC NAND memory, with specifically tuned firmware, to provide improved latency and consistency for read-heavy workloads. Using 192-layer QLC NAND flash memory on these drives not only allows Solidigm to provide high capacities and improve the maximum storage density per server, but it also minimizes power consumption. Peak power under load is up to approximately 25 watts with idle power of less than 5 watts. Solidigm also notes that the new D5-P5336 offers a 4x indirection unit U reduction versus the previous generation. The D5-P5336 is a 16 KB U drive, while its predecessor, D5-P5316, is a 64 KB U. Inside the aluminum chassis, which is smooth all around and doesn't feature integrated heatsink fins like the D7 series from both Intel and Solidigm, these drives feature some Skunix DRAM cache, in addition to the controller and NAND, and capacitors that enable power loss protection. Like previous general data center drives from Solidigm, the D5-P5336 series offers end-to-end protection from silent data corruption and includes a 5-year warranty, with endurance ratings of 0.02-0.58 full drive writes per day, up to 65.2 PBW on the 61.44 TB drive depending on the total capacity. These drives also support OCP 2.0 and are FIPS 140-3 Level 2 compliant. As you'd expect from a data center-focused product such as this, Solidigm offers management, update, and maintenance software for the SSD D5-P5336 series, for both Windows and Linux. The Solidigm storage tool, for Windows, pictured above, offers a modern GUI, with a few diagnostic and maintenance tools to keep the SSDs performing optimally. This is actually a universal tool that works with any Intel or Solidigm data center SSD. Intel Optane requires the Intel Mass GUI, which gives users the ability to perform such operations as updating the firmware, secure erasing drive or sending a trim command to the drive with the SSD optimizer to clean up cells that are no longer in use. Solidigm SSD D5-P5336 test setup and benchmarks. Under each test condition, the SSDs tested here were installed as secondary volumes in our testbed, with a separate drive used for the OS and benchmark installations. Our testbed's motherboard was updated with the latest BIOS available at the time of publication, and drives were left blank without partitions for some tests, while others required them to be partitioned and formatted. Windows Firewall, automatic updates, and screensavers were all disabled before testing, and Windows Quiet Hours, Focus Assist was enabled to prevent any potential interruptions. In all test runs, we rebooted the system, ensured all temp and prefetch data was purged, waited several minutes for drive activity to settle and for the system to reach an idle state before invoking a test. All of the drives featured here were tested with their own NVMe drivers installed where possible, available, but the default Microsoft NVMe driver was used when a proprietary driver was unavailable. Also note, we compare a mix of PCIe Gen 4 and Gen 3 drives here to illustrate how the Solidigm SSD D5-P5336 compares to other Solidigm drives we've previously tested and some competing offerings we have on hand. As we've noted in previous solid-state storage articles, though Iometer is clearly a well-respected industry-standard benchmark tool, we're not enamored with it for testing SSDs. The fact of the matter is, though our results with Iometer scale, it is debatable whether or not certain access patterns, as they are presented to and measured, actually provide a valid example of real-world performance. The access patterns we tested may not reflect your particular workload, for example. That said, we do think Iometer is a reliable gauge for relative available throughput, latency, and bandwidth with a given storage solution. In addition, there are certain higher-end workloads you can place on a drive with Iometer, that you can't with most other storage benchmark tools available currently. In the following tables, we're showing two sets of access patterns, a custom workstation server pattern, with a 128K transfer size, consisting of 80% reads, 20% writes, and 80% random, 20% sequential, access, and a 4K access pattern with a 4K transfer size, comprised of 67% reads, 33% writes, and 100% random access. Queue depths from 1 to 32 were tested. The Solidigm SSD D5-P5336 finished just behind the D7 series drives at QD1 when testing with the 4K, fully random access pattern, but pulls ahead of all the other drives once the queue depth is increased. With the 128K access pattern test, that features some sequential transfers, the Solidigm SSD D5-P5336 finishes just behind the higher-end D7 series, but is tightly grouped with the PCIe Gen 4 drives, and well ahead of the Gen 3 drives. The data presented here is the average bandwidth across all queue depth, with the access patterns we tested. As you can see, the Solidigm SSD D5-P5336 leads the pack with 4K random transfers. In the 128K test, the Solidigm SSD D5-P5336 ends up trailing the higher-end D7 series drive slightly, but it performs similarly to the other Solidigm drives overall. The Solidigm SSD D5-P5336's latency characteristics are strong across the board. In the 4K, fully random test, Only the Intel SSD D5-P5336 offered lower latency at the highest queue depth. In the 128K test, however, the Solidigm SSD D5-P5336 is tightly grouped with the other PCIe Gen 4 drives across all queue depths. ATO disk benchmarks, bandwidth and IOs. ATO is straightforward disk benchmark that measures transfer speeds across a specific volume length. It measures raw transfer rates for both reads and writes and graphs them out in an easily interpreted chart. We chose 0.5 kilobytes through 64 megabytes transfer sizes and a queue depth of 4 over a total max volume length of 256 megabytes. ATTO's workloads are sequential in nature and measure bandwidth and IOs, rather than response times, access latency, etc. The Solidigm SSD D5-P5336 is designed for read-intensive workloads, but this light-duty write test shows it competing well with the other PCIe Gen 4 drives, peaking just above its 3.3 GB per second rating. In the read test, the Solidigm SSD D5-P5336's performance tails a bit with transfer sizes in the 16 to 512K range, but it ramps back up and competes with the higher-end D7 series drives with the larger transfer sizes. Peak IOs across the various transfer sizes show the Solidigm SSD D5-P5336 leading WTIH the smallest transfers, but again we see things dropping off somewhat from 16 to 512K in the read test. SSoft Sandra physical disk test. Next we used SSoft Sandra, the system analyzer, diagnostic and reporting assistant for some quick tests. Here, we used the physical disk test suite and provide the results from our comparison SSDs. The benchmarks were run on clean drives that lacked any partitions. Read and write performance metrics are detailed below. The Solidigm SSD D5-P5336 faltered with this workload and ultimately finished behind the P4510 in the read test, but with writes that trailed the other drives. As SSD compression benchmark. Here we ran the compression benchmark built into as SSD, an SSD-specific benchmark being developed by Alex Intelligent Software. This test is interesting because it uses a mix of compressible and non-compressible data and outputs both read and write throughput across the drive. We only graphed a small fraction of the data, 1% compressible, 50% compressible, and 100% compressible, but the trend is representative of the benchmark's complete result. The compressibility of the data being transferred across the Solidigm SSD D5-P5336 has minimal impact on performance. In the read test, transfers are mostly flat, near the top of the charts. In the write tests, there is some variability, likely due to write caching, and the drive lands behind the P5430, but still up at the top of the chart. EFD Software's HDTune is described on the company's website thusly. HDTune is a hard disk utility with many functions. It can be used to measure the drive's performance, scan for errors, check the health status, SMART, securely erase all data and much more. The latest version of the benchmark added temperature statistics and improved support for SSDs, among a few other updates and fixes. HDTune Pro version 5.75, bandwidth and latency. The Solidigm SSD D5-P5336 competes favorably with the other PCIe Gen 4 drives we tested, but it ultimately slots in just behind the D7 series with both reads and writes. Latency is competitive as well, with results that compete favorably with other PCIe Gen 4 drives. Crystal Disk Mark is a synthetic benchmark that tests both sequential and random small and mid-sized file transfers using incompressible data. It provides a quick look at best and worst case scenarios with regard to SSD performance, best case being larger sequential transfers and worst case being small, random transfers. The Solidigm SSD D5-P5336 trails the D7 series drives in the sequential transfer tests here, and drops off considerably in the Q1T1 read test, though writes are in line with its rated specifications. In the random transfer tests, the Solidigm SSD D5-P5336 jumps into the lead in the Q32T1 test, but ends up trailing the rest of the pack at the lowest queue depth. For this next set of tests, we measured access latency at various queue depths with the same fully random IO meter 4K access pattern, 67% reads, 33% writes, featured previously, but while each of the drives was also under a sustained sequential write workload. A sustained sequential write across the entire volume was initiated, and when performance plateaued, Access latency was measured with iometer using the 4K fully random access pattern running concurrently. While under load, the Solidigm SSD D5-P5336's performance remains mostly consistent, with only a slight increase in latency under load. The Solidigm SSD D5-P5336 ends up leading at QD1 and QD8, but settles right in the mix with the other D7 and D5 series drives in the other test. Solidigm SSD D5-P5336 Summary and Conclusion. Solidigm is positioning the SSD D5-P5336 as a lower-cost option for read-intensive workloads, and our tests seem to prove that out. The Solidigm SSD D5-P5336 competed well with the other PCIe Gen 4 drives in terms of reads, especially when placed under higher loads, with more modest overall write performance. The ultra-high capacity Solidigm SSD D5-P5336 61.44 TB drive we tested put up competitive numbers across the board, mostly in line with its rated specifications. They haven't hit retailers just yet, so we couldn't check actual pricing, but Solidigm tells us they expect pricing to settle below D5-5316 series products of the same capacity. Solidigm D5-5316 drives can be found for approximately 8 cents - 10 cents per gigabyte as of today, which isn't much higher than some consumer class drives currently on the market. The Solidigm SSD D5-P5336 offers competitive overall performance in read-centric workloads, with solid latency characteristics, a good warranty, and what we expect to be competitive pricing, at a max capacity that currently can't be matched. Taking all of that into consideration, it's easy to recommend the Solidigm SSD D5-P5336 if it's the right drive for your storage environment. Thanks for watching this video. For more information, touch with us. Hello